This is question 85 from section 1.1. Determine a polynomial f that satisfies the following properties. f at x is equal to 9x minus 8. So the first thing we want to realize is this polynomial is of the first degree, right? Because the only variable has a degree of 1, so it's of the first degree. So we can assume that f, the original function, is also of the first degree, because if the original function is of the first degree, then the composition of f at x will yield in a function of the first degree as well. So a general equation or general function that we can write is f at x is equal to ax plus b, a being the coefficient for the x and b being the constant. So now f at x is going to be equal to a. Now for the x, you just plug in ax plus b, and then you just drop the b here. Because once again, it's the composition of f at x. Is if f at x is equal to ax plus b, f at x will have to be a times ax plus b because, well, I can show my step here. F at x is equal to ax plus b. So f at ax plus b will give you this right here. So now we can expand that. So let me write it again. f at x is equal to a times ax plus b. Now expanding that, you get a squared x plus ab plus b. And what I like doing is I like putting brackets around the ab plus b, because this just makes it more clear that the a squared has to equal 9 because it's the coefficient in front of x, and your ab plus b has to equal the constant negative 8. So looking at a squared first, we can see that a squared is equal to 9. Taking the square root of both sides to isolate for a, you'll get a is equal to plus or minus 3, because positive 3 times positive 3 is 9, and negative 3 times negative 3 is also 9. So now you can see that there's two cases to this problem. The first one being a is equal to positive 3. So if a is equal to positive 3, what will b be equal to? Once we find b, then we can find the equation f of x. So we know ab plus b, as I mentioned before, has to equal this constant negative 8. And we also know that a is equal to 3. So 3b plus b is equal to negative 8. 3b plus b, that's just collecting like terms. 4b is equal to negative 8. Divide by 4 on both sides. You get b is equal to negative 2. So when a is equal to 3, b is equal to negative 2. Now the second case would be when a is equal to negative 3. And in that case, you still have ab plus b is equal to negative 8. But now instead of positive 3, you'll have negative 3 for a. So negative 3b plus b is equal to negative 8. Once again, collecting like terms, negative 2b is equal to negative 8. Divide both sides by negative 2. You get b is equal to positive 4. So when a is equal to negative 3, b is equal to positive 4. So therefore, there's two equations, two functions that will satisfy this property. So the first one is f at x is equal to 3x minus 2. And once again, I'm just using this general form right here, 3x minus 2. And you have f at x is equal to minus 3x plus 4. These two equations satisfy this composition. And once again, there's two cases because we need to take the square root of 9, which yields two answers, a positive and a negative 3. So you get two equations.